Yes, hello there and welcome again to this class. Now, I want us to look at a chemistry Form 1 paper, and let's begin with the first question. So the first question is asking, define the term chemistry. So if you have been asked to define the term chemistry, so you can give two definitions. So one is a very short definition whereby it is chemistry is the study of matter and its properties. So that one is still right. So also you can say that this subject chemistry is the study of the structure, properties and composition of matter and the changes that matter undergoes. If you also give that definition of chemistry, you are going to get it right. However, if the question was asking define the term chemistry and you have been given about 2 marks, so you cannot just say it's the study of matter and its properties. You should give the full definition of chemistry, whereby you'll say that chemistry is the study of structure, properties and composition of matter and the changes that matter undergoes. So that full definition is the best definition to give. So the second question is asking, explain the following processes based on kinetic theory of matter. So here the main point is kinetic theory of matter. So I've been asked to explain about evaporation based on the kinetic theory of matter. So first of all, let's remind ourselves, what is kinetic theory of matter? So you see that this kinetic theory of matter simply states that matter is made up of tiny particles that are in constant random motion. So these particles will move from right to left as the state is changing from solid to liquid or going back from liquid to solid and vice versa. So in this case, we know that in this process whereby solid changes to liquid and then the liquid changes to gas, so this means that heat is going up. So there is actually the production of heat in this process. Whereas the process whereby gases change to liquid and then they come back to solid, so there's the decrease in temperature. So as heat increases, we know that the particles vibrate more and then they spread apart. As heat decreases, we know that the particles come close, the vibration decrease and the particles will come together. So let's look at evaporation. So what is evaporation in the first place? So this term evaporation means that is the change of state from from liquid to gas. So that is evaporation. If liquid changes to gas, that process is called evaporation. So in terms of kinetic theory of matter, actually what happens to these particles? So you see that in this evaporation, if the liquid is subjected to heat or the liquid increases the heat during heating, so what happens is that the particles of the liquid will begin to vibrate. So these particles will begin to vibrate and then the forces holding these particles together, which are called the intermolecular forces, will tend to become weaker. So if these intermolecular forces of the particles become weak, so these particles are going to vibrate as they move apart. So it will be like the particles will be repelling each other. So as these particles are moving apart, they are then going to form the change of state, which is now gases. So that is when now the liquids will change to gas. So in summary, about the evaporation, we'll say that as the liquid is being heated, so the liquid particles are going to absorb heat. So after absorbing heat, what will happen? The intermolecular forces holding these particles will become weak. So at the same time, the particles will again begin to vibrate even more. So as the intermolecular forces are becoming weak, the particles are vibrating. So we'll see that the liquid will now change state from being a liquid to being a gas. So as you can see, the gas particles are far apart. It will mean that the gas particles are vibrating, moving away from each other from the liquid. As you can see, the liquid particles are just spread apart, whereby the gas particles are widespread apart, forming now what is referred to as the gas. So what happens in freezing? So during freezing, in terms of kinetic theory of matter, we'll see that now freezing is decrease in temperature, whereby in liquid we decrease the temperature of liquid in order to become the solid. So this will be opposite of evaporation. So during freezing, what exactly happens is that there is the decrease in temperature of the liquid. So as the temperature decreases, we'll see that now the intermolecular forces will become stronger. So as the temperature decreases, the intermolecular forces become stronger. The particles will move now close together since the intermolecular forces holding them have become strong. So the particles will move close together, the vibration of the particles is also going to decrease. So as these three things happens, the intermolecular forces become stronger, the particles move close to each other, and the vibration of these particles decrease. Therefore, the liquid will change to solid. So as you can see, the liquid particles are spread apart, while the solid particles, they are closely packed together. So this is now the basis of the kinetic theory of matter in freezing, whereby the particles of the liquid will come together, the vibration of the particles will decrease, the intermolecular forces of the particles is going to increase, and the particles will come together now to form the solid. So remember, kinetic theory of matter, we only deal with the particles of matter. It states that matter is made up of tiny particles in constant random motion. So during freezing, when the temperatures goes down, so the particles will come together. When the temperatures goes up, the particles will tend to move apart. So the next one is melting. So let's see, what is melting? So melting is the change of state from solid to liquid. So we are basing our argument of kinetic theory of matter from solid to liquid. So what happens during melting in terms of kinetic theory of matter? So what happens is that as we increase the heat, or as we heat solids, what will happen is that the intermolecular forces are going to become weak. As the intermolecular forces have become weak, the next thing that will happen is that the particles of the solid will begin to vibrate. So as the particles of the solid begin to vibrate, the last step is that the particles vibrate moving apart. So since they vibrate moving apart, now they form the liquid. And that is the basis of melting in terms of kinetic theory of matter, whereby we'll say that as you heat solids, the intermolecular forces of the particles that are being held in the solid will tend to become weak. If these intermolecular forces become weak, the particles will begin to vibrate. Now the vibration of these particles will make the particles to move apart, as the solid will change state from being solid to being a liquid. So that is simply the basis of kinetic theory of matter in terms of evaporation that we have just explained, freezing and melting of matter. So let's go now to the third question, whereby the third question is asking, explain how sodium chloride can be prepared from a mixture of sodium chloride and water. So how can we be able to separate sodium chloride, the common salt that we have? How can we be able to separate that salt from its solution, from a mixture of sodium chloride and water? Now this is very simple. We can use two methods in this step. The first method we can use is simple distillation. The second method we can use is evaporation method. So remember, this question is not asking that how can we be able to also remain with water. It doesn't need water. We are only being asked, how can we be able only to remain with sodium chloride? That's why you can use evaporation. Now let's begin with evaporation. In the method of evaporation, for the definition of evaporation, we define this as the process whereby liquid changes to gas. And here, in terms of evaporation, we see that how can we be able to only obtain sodium chloride? So we can only be able to obtain sodium chloride when we heat the mixture. So if we heat the mixture and let the liquid evaporate to the atmosphere, or the liquid to leave, or the liquid to join the atmosphere, or the liquid to form gas, we will only remain with sodium chloride, which is the solute that you want. Now in this process, if we heat the solution, the liquid is going to evaporate. Since the liquid will evaporate, the only thing we are going to remain with is sodium chloride. And that's what the question is asking. How can we be able to remain with sodium chloride? So simply just heating the mixture of the solution, and then let the liquid evaporate, and you're going to remain with the sodium chloride. So that is one method. So the other method, we can use simple distillation, whereby simple distillation, this is the method of separating a solute from a solvent. In evaporation, remember, this is the method of separating a solute from a solution. That is evaporation, solute from a solution. While simple distillation, this is the method of separating a solute from a solvent. So why do we say solute from a solvent? It's because in simple distillation, this side will remain with solute, this side will remain with solvent. So since in simple distillation we remain with both of them, this side solute, this side solvent, so that satisfies the simple distillation. While in evaporation, we separate the solute from the solution. So why is it solute from the solution? It's because in evaporation, we only remain with the solute. We don't need the solvent. So in evaporation, we only remain with the solute. So since we only remain with the solute, that's why we say evaporation is the method whereby a solute is separated from the solution. Simple distillation is the method whereby we separate a solute from a solvent. Now in this process, in this step we can use simple distillation, whereby you see that it is possible for us to separate these two things. If we heat the mixture or if we heat the solution, we see that water is going to be collected on the other side. Rather, the liquid is going to be collected on the other side, as the solute, which is now the sodium chloride, is going to be collected on this other side. And that satisfies the question, whereby the question is asking, explain how sodium chloride can be separated from a mixture of sodium chloride and water. So we can use those two methods, evaporation or simple distillation. So remember, we have two types of distillation, whereby we have fractional distillation and simple distillation. Fractional distillation, remember, we separate two miscible liquids with close or with different boiling points, while simple distillation, we separate solutions only. Simple distillation, kumbuka, it's solutions. Fractional distillation, remember, it's miscible liquids. So don't forget that. So question number 4 is asking, below is a chromatogram, study it and answer the questions that follow. So below is a chromatogram, study it and answer the questions that follow. So the first question is asking, name the colors present in ink letter A. So the colors present in ink letter A, we are just going to check the pigments of A are on which same line with the pigments of the other pigments that are in the chromatogram. So in this case, we see that pigment A is exactly on the same horizontal line like the red eye. So it means that one color in ink A is red color because they are on the same horizontal line, as you can see. So the next one is ink blue, the blue color. So since they are on the same horizontal line with ink A, it will mean that ink A has the red color since they are on the same horizontal line, and the other one is blue color since they are also on the same horizontal line. So the next question is asking, which method can be used to obtain each color? So the method that can be used always in chromatography, if you have been asked this question, which method can be used to extract, because this question is asking, which method can we use now to remove or to extract one color from the chromatogram? So remember, always remember the method is solvent extraction, and the best solvent to use in this method is always propanol. So the best solvent to use is propanol, and the method is solvent extraction. In solvent extraction, we can be able to remove only the yellow color, only the blue color, or extract only the red color. So don't confuse this with chromatography, because chromatography is the method of separating colors. In chromatography, we separate colors. By using solvent extraction, we can be able to remove only that one color from the chromatogram. So don't confuse between these two things, solvent extraction and chromatography. But anytime in the exam, you will be asked this question, which method can be used to remove or to obtain a color from the chromatogram? The method is always solvent extraction. If you have been asked which is the best solvent to use in this method, the best solvent always to use is propanol solvent. You can also use ethanol, you can use methanol, etc. But the best one to use is the propanol. So the next question is asking, state two methods making it possible for the pigments to be separated. So this is simple. So first of all is solubility of the pigment. If the pigment is more soluble in water, or if the pigment is more soluble in the solvent that you are going to use, therefore it is not going to spread a long distance. But if it is less soluble, it's going to spread a long distance. Also, we see the density. If the pigment is denser or it's heavier, it's going to move a short distance. But if the pigment is less denser, it's going to move a very long distance towards the solvent front. Also, we see viscosity. If the pigment is more viscous, it's going to move a very short distance. But if the pigment is less viscous, it's going to move a very long distance. Like for viscosity here, we can compare between porridge and water. So what is viscosity? Viscosity is the ability of liquid to be able to flow. That is viscosity in terms of physics. It's the ability of the liquid to be able to flow. Now in this case, we see that if a pigment is more viscous, like for example, the porridge is more viscous. If a pigment is more viscous, it's going to move a very short distance and then stop. But if a pigment is less viscous, example, we can use water in this case. So if a pigment is less viscous, it's going to move a very long distance. So state two methods making it possible for the pigment to be separated. So what makes it possible is, first of all, the solubility of the pigments. The second one is the viscosity of the pigment. And then the third one is the density of the pigments. So letter D is asking, the graph below shows heating curve of water. Then Roman 1 is asking, at what temperatures does water boil? So according to this graph that you can see, like according to this graph, at exactly 100 degrees Celsius is whereby the water will begin to boil, at exactly 100 degrees Celsius. So why do we say 100 degrees Celsius? So remember, this graph, first of all, represents an impure form of water. So this is impure water. But let's look at the regions. So part AB. So remember, always if we have an inclined line, always an inclined line means that we are absorbing heat. So in this case, this graph represents a heating curve or a heating graph, because this graph represents a heating graph whereby the graph goes from bottom to up, going towards the right. Whereas if we have that other graph whereby we are originating from the top going to the bottom, that is a cooling graph. So in this case, this is a heating graph. So region AB simply is absorption of heat. So the water is absorbing heat, or the solid water or ice is absorbing heat. Therefore, our region BC, even though this is an impure solid, the region BC should stand for the change of state from solid to liquid. But remember, this is still impure water. So region BC, this should be change of state from solid to liquid. Then region CD also should be absorbing heat. So the liquid is now absorbing heat. So remember, region BC is that there's the change of state from solid to liquid. Now region CD should now be, again, the liquid is now absorbing heat, awaiting to change to gas. So when it reaches exactly point D, it should be now evaporation which is taking place. So the question is asking, at what temperatures does water boil? So that is point D. What is boiling point? So boiling point refers to the point whereby liquid changes to gas. That is the boiling point. So in this case, at what temperatures does water boil? So that is 100 degrees Celsius, which is point letter D. So the next question is asking, is this curve for pure or impure water? So this curve simply shows impure water. Why do we say this curve is an impure water? It's because for a pure water, it should have exactly, so the horizontal should be exactly horizontal, not inclined. So the horizontal must be exactly horizontal, which means the change of state. Then remember, the absorption of heat, we say that the absorption of heat here should be an inclined line. But in this case, we see that we don't have any horizontal line. So since we don't have any horizontal line, it simply means that this water is an impure water, because where should be the change of state, we still have an inclined line. As you can see for the BC, it's inclined, it's not horizontal. So since it's not horizontal, again remember, this is impure water. Also region DE, whereby it should be the water is changing state from liquid to gas. This region of change of state DE is also not horizontal. It should be purely horizontal. So due to BC being inclined, DE being also inclined, we can say that this water is not pure water. It's impure water because it doesn't have sharp melting and boiling points. So Roman 3 is asking, what is the effect of impurities on melting and boiling point of water? So this is simple. If we add impurities in water, so the impurities, they lower the melting point and they raise the boiling point. So that's what happens in impurities. So impurities in everything, impurities, they will always lower the melting point and they will always raise the boiling point. Like for example, if we just give a rough example of just water, a rough example of water. If we add impurities to water, let's say we have added sodium chloride to water. So what will happen is that the water will melt at about negative 75 degrees, or not negative 75, let's say about negative 5 degrees Celsius. So the water will melt at about negative 5 degrees Celsius and it will boil at about 125 degrees Celsius. So that's all about impurities. So the impurities, they lower the melting point, then they increase the melting point, the boiling point. So they lower the melting point and increase the boiling point. So question number 5 is asking, what does the following arrows indicate in a chemical reaction? So the first arrow, letter A. So given this arrow always indicates a forward reaction. So letter B, this arrow always indicates a backward reaction. Letter C, if you have been given those two arrows, complete arrows. So you have that complete arrow and the other complete arrow facing the other side. So if you have been given these two complete arrows facing opposite direction, so they mean that this reaction is reversible. So these arrows means reversible reaction. So for example, letter D, if you have been given those half arrows, so one half arrow is pointing to the right, one half arrow is pointing to the left. So if you have been given the half arrows pointing opposite direction, so this means that the reaction is it means an equilibrium reaction. So those ones, you are going to look at them when you reach Form 4. So those simply mean equilibrium reaction. So question number 6 is asking, state 3 examples of acids in the laboratory. So here we have very many acids. So we have, for example, we have nitric acid, we have citric acid, we have sulfuric acid, we have hydrochloric acid, we have ascorbic acid, we have acetic acid, we have oxalic acid, whereby the other name of oxalic acid is ethanedioic acid, and we also have the acetic acid that I have just mentioned. So the acetic acid, I know you have ever been in contact with, like for example of acetic acid, we have vinegar. So vinegar is an example of acetic acid. So whereby you will see that vinegar is used in food preservation, and also vinegar is used is also added to food that is rich in fat in order to remove or scrub off the fat from the food. So the next question is asking, list any 3 bases used in the laboratory. So bases, as long as you give a hydroxide at the end of any metal, that is a base. That is the simplest way to identify a base. For example, we have potassium hydroxide, we have sodium hydroxide. The other common base, we have calcium hydroxide. We have, you can also give aluminium hydroxide. We can also give, first of all, the calcium hydroxide, which is the lime. So it's also called the lime water, whereby this lime water is always used for the testing for the presence of carbon 4 oxide. So these ones we are going to look at them in the upcoming classes. So whereby the lime water is used for the testing of the presence of carbon 4 oxide. Sodium hydroxide is used in making soap, etc. So as long as you mention any metal and give it a hydroxide at the end, you are good to go. That is the simplest way by which you can be able to identify the bases in the laboratory. So the next question you are being asked, define the term pH scale. So the pH scale will say that this is a scale which ranges from 0 to 14, whereby it shows the strength of acids and bases in the laboratory. So as you can see, this is the pH scale, whereby some pH scale may range from 1 to 14, some pH scale may range from 0 to 14, but as long as you say this is it's a scale which ranges from 0 to 14, which shows the strength of acids and bases in the laboratory, so it will be correct. So in the pH scale, we see that the readings from 0 to 3 this simply implies that these are strong acids. So 0 to 3, these are strong acids, whereby we have hydrochloric acid, sulfuric acid, nitric acid. Most of the mineral acids, like those three I've just mentioned, these are mineral acids. So the mineral acids, including citric acid, which is an organic, the mineral acids are mostly found in the strong acid category. So regions 4 to 6, these are weak acids, whereby we have ascorbic acid, vinegar, etc. So in 7 is neutral. So these are neutral substances, like for example, we have sodium chloride solution, we have water, etc. So from 8 to 10, these are now bases. So this other side simply imply bases. The other side from 0 to 6, these are acids, 7 is neutral, 8 to 14, these are bases. So region 8 to region 11, region 10 rather, these are weak bases. And then from region 12 to region 14, not 12, region 11 to 14, these are strong bases, whereby we have potassium hydroxide, sodium hydroxide, calcium hydroxide, we may have magnesium hydroxide, etc. So this is the pH scale. It shows the strength of acids and bases. So don't forget, in the laboratory we have other indicators, whereby the pH scale is one of the indicators. So we have other indicators whereby we have methyl orange, we have methyl blue, we have litmus paper, we have bromotyl blue, we have phenolphthalein indicator, and also we have plant extracts, whereby in an exam, if you have been asked, state or name any natural indicator that can be used in the lab. So the natural indicator you can use in the lab, we have plant extract, whereby you get the flower extracts, the different colors of the flower, you crush them using a pestle and a mortar, then that liquid is a very nice natural indicator, whereby if you drop that liquid in acid, it will give you a characteristic color. If you drop it in base, it will give you a characteristic color. If you drop it in neutral, again it will give you a characteristic color. So the flower extracts are the only natural indicators that we have in the laboratory. So apart from that, we have the next question, differentiate between sublimation and deposition. So sublimation, remember the three states of matter, whereby we have solid, liquids, and gases. So the point whereby the solid changes to liquid, remember this, we say that this is melting. Melting is the process whereby solid changes to liquid. So the process whereby liquid changes to gas, this we call it evaporation. So in evaporation, the liquid changes to gas. So don't forget that. So going this other side whereby the temperatures are now reducing, we'll see that the process whereby gases change to liquid is called condensation, and the process whereby liquids change to solid, this process is called freezing. So remember, the process whereby solid changes to liquid, liquid changes to gas, there's the increase in temperature. The process whereby the gas changes to liquid and the liquid changes to solid, there is the decrease in temperature. Now, the process whereby solid changes straight to gases is called sublimation. So don't forget that. Sublimation is the process whereby solid changes straight from solid to gases, skipping the liquid phase. Whereby deposition is the opposite of sublimation. Deposition is the process whereby now the gas will change straight to solid. So they are going to skip the liquid phase. So the gas is going to change straight from being a gas to being a solid. So what are the examples of the substances of matter that undergo deposition or sublimation? The first one, we have iodine, whereby the gray crystals of iodine are going to change to a purple vapor of iodine gas. So we have iodine that undergoes deposition and sublimation. We have cobalt 2 chloride. We have aluminium 3 chloride. We also have iron 3 chloride. We also have phosphorus 5 chloride. We also have benzoic acid. We also have dry ice. So all of these undergo sublimation and deposition. So if you have been asked in an exam to list examples, so you can give any of those examples and you'll be correct. So that is sublimation and deposition process. So the next question is question number 10, which is asking, brine is made by mixing water and common salts. Give the names of the following. So brine, what is brine? So brine is a very high concentration of sodium chloride solution. So that very high concentration of sodium chloride solution is referred to as brine. So if we have said solution, it will mean that this solution has sodium chloride, which is the solute, and then it has water, which is the solvent. So let's get back to the question. The question is asking, brine is made by mixing water and common salt. So those two things, mixing water and common salt. Give the names of the following. So Roman 1, letter A is asking solute. So in this mixture, remember this mixture of water and common salt, that solution, they'll form the sodium chloride solution. So the question is asking, give the names of the solute. What is a solute? A solute is any solid which dissolves in a solvent. So any solid dissolving in a solvent, that is a solute. In this case, even we have the answers right in the question. We already have the answers. So common salt is our solute because the common salt is dissolving in water. So since it is dissolving in water, so that automatically becomes the solute. So the next one, which is B, give the names of the following, the solvent. So what is the solvent here? So the solvent is water. Why did you say that water is the solvent? It's because water is the one responsible for dissolving the sodium chloride, which is the solute. So since water, being the solvent, dissolves the solute, which is the sodium chloride, so water becomes the solvent. What did we define the solvent as? We say that a solvent is any liquid that dissolves the solute. So that is the solvent. Any liquid dissolving the solute is referred to as a solvent. Solute, we say that solute is any solid dissolving in a solvent. That is a solute. Any solid dissolving in a solvent. But if we mix now the solute and the solvent, if we dissolve now the solute in the solvent, what is the name given to that mixture? So that mixture is called a solution, whereby a solution is made by dissolving a solute in a solvent. So don't forget those three terms. The term solute, what is a solute, solvent, what is a solvent, and then solution. So solution is solute plus a solvent. So let's go to the next number, which is number 12. So number 12 is asking, write an equation between hydrochloric acid and the first one is zinc metal. So what is the equation? Complete the equation. What happens when hydrochloric acid reacts with zinc metal? So if you have been given this question in exam, they expect you to complete that equation. Hydrochloric acid reacting with zinc metal. So this is what you'll do. And in Form 1, you are only allowed to write the word equation. From Form 2 up to Form 4 up to university, they will now use the chemical equations. But in Form 1, you are only allowed to write the word equation. But just for the sake of revision, we are going to do both of them, the word equation and the chemical equation. So the question is asking, write an equation between hydrochloric acid and zinc metal. So we'll have zinc metal reacting with hydrochloric acid. So we are going to get zinc chloride because hydrochloric acid is going to release chlorine. The chlorine gas from the chloride is going to release the chlorine. Therefore, the zinc is going to react with the chlorine to get zinc chloride. So the equation is zinc plus hydrochloric acid, you're going to get zinc chloride plus hydrogen gas. So you remember those general equations we formed. When an acid reacts with a metal, we form salt plus hydrogen gas. So in this case, our salt is zinc chloride and then plus hydrogen gas. So that's what happens in the first reaction. So in the second reaction, we have also still a metal reacting with the acid. So the second one is sodium metal. So for the sodium metal, we see that sodium plus hydrochloric acid, so we are going to get sodium chloride, which is the salt, plus hydrogen gas. Again, remember the general equation. When an acid reacts with a metal, we get a salt. In this case, we have sodium chloride plus hydrogen gas. So don't forget that. So the next one, we have somewhat of a base, whereby we have magnesium oxide, which is our solid base. So what happens when an acid reacts with a base? So acid plus a base, you get salt plus water. Now, if an acid reacts with a base, we'll now get salt plus water. If acid reacts with a metal, we get salt plus hydrogen. But if an acid reacts with a base, we get salt plus water. So in this case, we have magnesium oxide, which is a solid, reacting with hydrochloric acid. So if these two react, we are going to get magnesium chloride plus water. So that's what we are going to get. Again, remember, if an acid reacts with a base, it's salt plus water. And that's why here we are getting magnesium chloride, which is the salt, plus molecules of water. So don't forget that. Remember the general equation. When an acid reacts with a metal, we are going to get salt plus hydrogen gas. If an acid reacts with a base, we are going to get salt plus water. If an acid reacts with a metal carbonate, we are going to get salt plus water plus carbon 4 oxide. Because since it's a carbonate, it must release carbon 4 oxide. So if an acid reacts with a carbonate, we get three things. And remember, carbonates are bases. So remember that carbonates are bases. So acid plus a base is salt plus water. But since it is a carbonate, it must give carbon 4 oxide. So acid plus a metal carbonate, so we're going to get salt plus water because it's a base. But since it's a carbonate, we must get plus carbon 4 oxide. So the next question is asking, differentiate between hydrated and anhydrous salt. So the difference between hydrated and anhydrous salt. So hydrated salt, these are salts which have water of crystallization. So that is hydrated salt. It's a salt which has water. It's a damp salt. Like maybe, for example, if you take that salt from the house and you add some water, that becomes hydrated salt. So you don't call it a wet salt. You call it in chemistry hydrated salt. So hydrated salt, remember, this is a salt having water. So it's a salt that has been added water. So that is hydrated salt. So hydrated salt, the definition will say that these are salts having water of crystallization. So that's the best definition for hydrated salt. So the next one is anhydrous salt. Anhydrous salts, these are salts which do not have water of crystallization. In short, these are salts which are dry. They don't have any trace of water. These are dry salts. That is anhydrous salt. So remember, always in an exam, if you have been asked to differentiate, there are two methods of differentiating. You can use a conjunction whereby you say that hydrated salts are salts having water of crystallization, while, that's the conjunction, while anhydrous salts, these are salts that do not have water of crystallization. If you don't use that conjunction between these two things, you're going to get it wrong, because you must show the relationship between the first bit and the second bit of the question. So you must use a conjunction. So the other method by which you can be able to differentiate, you can use a table to differentiate. If you don't use a table, then use the conjunction. If you don't use the conjunction, use a table to differentiate, whereby you can say this side is hydrated, that side is anhydrous, and say that hydrated salt, these are salts which have water of crystallization. Then the table, anhydrous salt, these are salts that do not have water of crystallization. Again, remember, if you just say hydrated salts, these are salts having water of crystallization, then below it anhydrous salt, these are salts which do not have water of crystallization, you will get it wrong, because the question is asking differentiate. What you are doing in that case, you are stating, that is stating, or that is just describing. It means that you did not follow the rules of the question. So remember, differentiate, use a conjunction or use a table to be precise. So like for example, we have anhydrous cobalt 2 chloride, which is blue in color. So anhydrous means it doesn't have water. So this salt, which is cobalt 2 chloride, is blue in color. So anhydrous cobalt 2 chloride is blue in color. If we add some water to that anhydrous cobalt 2 chloride, the color changes from blue to pink color. So for the pink color, we'll say that this is now hydrated cobalt 2 chloride. So anhydrous, remember, it doesn't have water of crystallization. It is blue in color, cobalt 2 chloride. But hydrated, if we add some water to the anhydrous, it becomes hydrated, which is pink in color. Now the most common salt that is used even in schools, okay, it's readily available, is copper 2 sulfate. So anhydrous copper 2 sulfate is always white in color. If you take this white copper 2 sulfate anhydrous and you add some traces of water, the white color is going to change to blue. Therefore, we are going to have now blue hydrated copper 2 sulfate solid. So remember, anhydrous, they don't have water of crystallization, while hydrated, they have water of crystallization. So don't forget that. So let's go to the next one, which is question number 14. We have been asked or told, study the diagram and answer the questions that follow. As you can see, we have this diagram, we have this setup, and we have liquid mixture Y, sorry. There is some heat going on. We have a thermometer, then we have that apparatus X, and then we have the other apparatus, which is Y. So the first question is asking, name the apparatus X and Y. So now some students were complaining that the question has a mistake. Now the question doesn't have mistake. We urge them to be careful with the readings of the readings and the markings on the apparatus. So you see, for letter Y, that is an apparatus labeled Y. But for this other Y, we have liquid mixture Y. So that is liquid mixture Y. That is the liquid, which is Y. The other one is apparatus Y. So they are really confusing. So the first question is asking, name the apparatus X and Y. So the apparatus X is the fractionating column. The fractionating column, remember, inside the fractionating column, we always have glass beads. What is the function of the fractionating column in this experiment? So fractionating column assists in condensation, or enables the process of condensation to take place. So remember, as we are heating the liquid, so the liquid is going to evaporate. So as the liquid is evaporating, it's going to get the glass beads on the fractionating column, and these glass beads are going to accelerate the process whereby this gas is going to condense to form the liquid, as the liquid will now flow over the Liebig condenser. So the function of part labeled X, if you have been asked, you will say it is to accelerate the condensation of the vapor coming from the round bottomed flask. So what's the name given to the apparatus labeled Y? So the apparatus labeled Y, this is the Liebig condenser. So the Liebig condenser also accelerates the process by which the vapor passing through is going to condense and then flow on the other side as the distillate. So remember, part X accelerates condensation, that is the fractionating column. Part Y, which is the Liebig condenser, also accelerates condensation by passing in very cold water from the bottom and removing the hot water from the top. So the function is also to accelerate the condensation. So question letter B is asking, what is the name given to apparatus Y? So apparatus Y is referred to as the Liebig condenser. So the question had been repeated, so that was the Liebig condenser. So question letter C is asking, what is the name given to the above experiment? So as you can see, this experiment might be confusing to the... Okay, we have two experiments that they tend to look similar. This one is simple, this one is fractional distillation. We also have simple distillation, which might take almost the exact same form as this one. But how can you be able to differentiate between fractional distillation and simple distillation? So this one is fractional distillation. Why did we say this one is fractional distillation? Because you see, what is being heated is going to give you the hint if this is the fractional or simple distillation. Remember, fractional distillation definition is that this is a method of separation whereby miscible liquids are separated. Fractional distillation, remember, we deal with miscible liquids. Simple distillation, we deal with solutions. So in this case, we are being told that this is liquid mixture Y. So since this is liquid mixture, it automatically becomes fractional distillation. But if we could have been told that this is solution, that could have been simple distillation. Because simple distillation, remember, we separate a solute from a solvent. This side we obtain the solute, this side we obtain the solvent. But fractional distillation, we separate two miscible liquids based on different boiling points. So in this case, what is being heated will tell you, is this fractional or simple distillation? In this case, this is not solution being heated, it is liquid mixture. So automatically it becomes fractional distillation. So remember, also simple distillation will have everything here. we'll have the fractionating column, we'll have thermometer, we'll have the Liebig condenser, etc. But what will tell you this is simple is if down there we're heating a solution. What will tell you that this is fractional, down there what you're heating is miscible liquids or liquids, that is fractional distillation. So question number 15 is asking, state 3 importance of studying chemistry. So the importance of studying chemistry, they are very broad. There are very many. If you can just take a topic in chemistry and say the importance you learn in that chemistry, that is just an importance of studying chemistry. Because, like for example, we see in chemistry, we learn to differentiate between acids and bases. That is the first and the simplest importance of studying chemistry. Also the topic of drugs. In chemistry, we learn the different types of drugs. Also in chemistry, we learn the negative effects of drug abuse. So there are very many. Also in chemistry, we learn techniques like analyzing, experimentation, drawing tables and graphs. There are very many. Also in chemistry, you can say we learn how to manufacture different types of drugs. Also in chemistry, you can say we learn how to extract and purify different metals based on the topic of metals in Form 4. So for this importance of chemistry, it's very broad. It's a very broad area of chemistry whereby you can just say the importance, that one important thing you learned from any topic, and it can fit to be an importance of chemistry. So the next question is asking, question 16, state 2 differences between luminous and the non-luminous flame. So remember the luminous flame, this is the flame of the candle. That's the simplest way to understand. Luminous flame is the flame of the candle, while non-luminous flame is the flame mostly produced by the cooking vessels like the gas cooker. So again, this question is asking about the differences. So there are 2 methods of giving differences. So you can give differences by using a conjunction, or you can give differences by using a table. So we can use either. By now, let's just choose the method of conjunction. Let's just use the conjunction, whereby you'll say that the luminous flame is yellow in color, while the non-luminous flame is blue in color. Also the other one, you can say the luminous flame is produced when the air hole is closed, while the non-luminous flame is produced when the air hole of the Bunsen burner is open. So the other difference, you can say that the luminous flame is used for producing light, while the non-luminous flame is used for producing heat, or is used in cooking or in heating. So really much avoid giving negative answers. So avoid using negatives when giving difference. So this is what I mean. Avoid giving negatives like this. The luminous flame is used for lighting, while the non-luminous flame is not used for lighting. So avoid giving negative in your differences, because these negatives will earn you a 0 back. So if there's anything you can say on the other side, it's best you say it, other than using the negative. There are instances that you cannot avoid using negatives, but if there is something you can say on the other side, say that thing, but avoid using the negative, because if you use the negative, you're going to get it wrong. So it is not correct to say the luminous flame is used for lighting, while the non-luminous flame is not used for lighting. That is wrong. What you should say, give the function of the other one. You have said the function of this one, so give also the function of the other one, like this. The luminous flame is used for lighting, while non-luminous flame is used for heating. So I have avoided using the negative. So that is now correct. So the other difference, you can say that the non-luminous flame has 4 regions, while the non-luminous flame has 3 regions. So the luminous flame has 4 regions, while the non-luminous flame has 3 regions, among others. So also you can say, you can also talk about soot. And you can say that the luminous flame produces soot, but here we can use the negative. Luminous flame produces soot, while non-luminous flame does not, because that is the best we can say on the other side. So the luminous produces soot, while the non-luminous flame does not produce soot. So luminous flame burns silently, because you cannot hear the sound of the candle burning. So the luminous flame burns silently, while the non-luminous flame burns with a roaring sound or burns producing noise. So those two differences and all the other differences at large. So make sure that you have known these differences, and if possible, avoid using negatives in giving the differences. And also remember this, in giving the differences, you can use the table or you can use conjunction. So those are the two best methods for differentiating. If you don't use either, you're going to get it wrong in the difference question. So letter B is asking, below is a diagram of the Bunsen burner. Use it to answer the questions that follow. So name the following parts. Part A. So part A, we have the chimney. Part B, we have the collar. So that part is the collar. Part E, we have the air hole. That was the air hole. And then part F, we have the gas pipe. So part C, we have not named part C. So part C is the base, and part D, that is the flame. So what if you have been asked in an exam, define the part labeled D. So define that part labeled D, or in short, define a flame. What is a flame? So you'll say that a flame is a mass of burning gases. So that is a flame. A flame is a mass of burning gases. So we have two types of flame. Again, remember, we have the luminous flame and we have the non-luminous flame. So question number 17 is asking, state three apparatus used for heating in the laboratory. So three apparatus used for heating. Now this question is simple because you can give anything that can be used to produce heat. That is the correct answer. The only thing that you should not give is a matchstick. Don't say a matchstick. You cannot use a matchstick to produce heat in the lab, because how many matchsticks are you going to light in order to produce heat in the lab? So that is the only one which is not correct. But anything that can be able to produce heat can be used as heating apparatus in the lab. Just anything. Like for example, we have the most common, which is the Bunsen burner. We have a candle, we have a jiko, we have a lantern, for example, we have a lighter, we have electric heater. So anything that can produce heat, that can be able to use as a heating apparatus in the laboratory. So always remember that. So the next question is asking, state two categories of drugs. Now the two categories of drugs we have here, first of all, we have the legal drugs. So the legal drugs, these are the drugs which have been permitted by the government to be used in a particular country. So those are the legal drugs. The illegal drugs, these are drugs which have not been permitted by the government to be used in a particular country. Like for example, we have the cocaine, the mandrax, we have the bang, we have the mira. Such are illegal drugs. And also morphine, whereby you see that morphine is used in the hospitals, but you cannot be able to buy morphine because morphine should only be used in special conditions. So morphine out here is an illegal drug, but can be used in terms of saving lives in hospitals, in terms of operations. So the long operations, they use morphine in order to remove the pain from the patient. So we have those two categories of drugs, whereby we have the legal drugs, drugs permitted to be used in a particular country by the government. Illegal drugs, drugs which have not been permitted to be used in a particular country by the government. So the types of drugs, if you have been asked this question, list the types of drugs. So the types of drugs, remember, we have now painkillers, we have curative drugs, we have the sedatives, we have the antidepressants. So those are now the types of drugs. We have different, there are many types of drugs, but those are now the types of drugs. Remember, if you have been asked categories of drugs, two categories we have, legal and illegal. If you have been asked the type of drugs, now give those kina painkillers, kina curative, kina sedatives, antidepressants. So give all those. But remember, don't confuse this with the categories of drugs. Now, if you have been asked now examples of drugs, if you have been asked now examples of drugs, now give like kina bangi, kina tobacco, mandrax, etc. So those are now examples of drugs. Students tend to confuse. So don't confuse between the categories of drugs the type of drugs, and now the examples of the drugs themselves. So question number 19 is asking, state two differences between temporary and physical change. So the other name of temporary change is physical change or reversible change. The other name of permanent change is irreversible change or chemical change. So it can be called either of those names for temporary, either of those names for physical. So for the temporary change, we see that no new substance is formed in temporary change, while in permanent change, a new substance is formed. So that is one. So also in temporary change, there are no heat changes. So for example, if you mix maize and beans, so there are no heat changes. So they are just going to mix. While in permanent change, it must be accompanied by heat changes. Either the temperatures are going to go up or either the temperatures are going to go lower. So in chemistry, we call it, in permanent changes, there is either an exothermic reaction or an endothermic reaction. So take note. So for the temporary change, we'll say that temporary change is a physical change, while in permanent change, this is a chemical change, whereby in permanent change, it mostly involves the mixture of different chemicals in order to bring the product. So we see that the temporary change are reversible. It means that if you mix maize and beans to form githeri, it is reversible. You can be able to remove the beans and the maize and remain with maize only and beans. And also in a candle, if we have that solid candle, if you heat that candle, it's going to change state from being a solid to being a liquid. That is a temporary change, because if you cool this liquid wax, it will form the solid wax, whereby the solid wax is where you began from. The solid wax is where you began from before you began heating to change to the liquid. So in temporary change, these changes are reversible. You can be able to go back to where you began. While in permanent change or in chemical change, these changes are irreversible. If you mix sodium and chlorine, you get the salt, which is sodium chloride. There is no way again you are going to get sodium only and chlorine gas. So in chemical change, if you get the product, that product is final. You will never again get the reactants that you began with. So the other one is, in temporary change, there is no change in mass, while in permanent change, there is change in mass. So you should take note of that. So question number 20 is asking, state three differences between acids and bases. So state three differences between the acids and bases. So first of all, in terms of taste, we see that acids, they have a sour taste, while bases, they have a bitter taste. So again, remember, this is differentiating. We can use a table or conjunction. So acids have a sour taste, while bases have a bitter taste. So also we see in terms of pH scale, the acid ranges from 0 to 6 in the pH scale, while bases range from 8 to 14 in the pH scale. Also, let's look at dissolution in water, and we'll see that for the acids, if we dissolve acid in water, they produce hydrogen ions. And if you dissolve bases in water, they produce hydroxyl or hydroxide ions. So take note of that, whereby the definition of an acid, we can define an acid as, these are substances when dissolved in water, they produce hydrogen ions, while bases, these are substances when dissolved in water, they produce hydroxide or hydroxyl ions. So the next one is corrosion, whereby we see that acids are corrosive while bases are not corrosive. So the other one is about the litmus paper. We see that acids change the blue litmus paper to red, while bases change the red litmus paper to blue. So take note of that. So the acids change the blue litmus paper to red, while the bases, they change the red litmus paper to blue. Among others, we have those differences. And also, acids react with metal to give salt and hydrogen. So that is acid. They react with metals to give salt and hydrogen, while bases do not react with metals. So the bases mostly do not react with metal. That's what you can say. Acids Most acid reacts with metal, while bases, they rarely react with metals. So apart from that, let's go to the next question, which is question number 20. So name any two components of air. So the components of air that we have different components of air. Like for example, we have nitrogen, which is the largest, having 78%. We have oxygen, which is the second, having 21%. We have carbon 4 oxide, which has 0.03% in the atmosphere. We have inert gases, which mostly is represented by argon, which has 0.97% of air. And then we have water vapor in the atmosphere, which ranges in different geographical areas. Because in areas whereby there is a large water body, the amount of water vapor in the atmosphere is going to be high. In the areas whereby we have plains, the amount of water vapor is going to be lower. So that's why water vapor is not given a specific percentage when looking at the components of air, because the amount of water vapor in the atmosphere ranges in different geographical locations, as well as dust. So the other component is dust. Also, the amount of dust in the atmosphere ranges in different geographical locations, and that's why also dust has not been given a specific proportion of the atmosphere. So these are the components of the atmosphere. And if you can remember, there's a method by which each component of this can be able to be separated, whereby, first of all, in separation of liquid air, the air is passed through filters, whereby in the filter we remove the dust particles. Remember that. In the filters, we always remove the dust particles. So the air that is flowing in the air that is now flowing from the pump, intake pump, going forward doesn't have any dust, because we have already removed the dust. So the air is going to flow through the compressor, the air is going to flow through the freezer in order to remove the water vapor, in order to bring the air to be in form of liquid, which happens mostly in the compressor, whereby the air is compressed and then left to expand, and then left and then compressed again, like under 200 degrees Celsius at 200 atmosphere, in order to form now the liquid air. So this liquid air then enters the fractional distillation chamber, whereby we separate nitrogen, which evaporates first at negative 196 degrees Celsius, followed by argon at negative 186 degrees Celsius, and then lastly we have oxygen to be separated at negative 183 degrees Celsius. So this one we covered in the previous class, so if you didn't check, please go and check the methods of separating liquid air. So after that, let's go to the next question, which is asking, list any 3 indicators used in the laboratory. So we have very many indicators used in the laboratory. First of all, we have the natural indicator, which is from the flower extract. After that, we have the litmus paper, the blue and the red. We have the bromotyl blue, we have the methyl blue, we have the methyl orange, we have the methyl red. We have the litmus paper we have mentioned, we have the pH scale, we have the phenolphthalein indicator. We have different types of indicators that can be used in the lab, and these are some of them. So the last question is asking, define the term indicator. So what is an indicator? So an indicator, this is a substance which identifies or differentiates between acids and bases. So those are indicators. So the indicators mostly, they differentiate for us if this is an acid or this is a base, because you cannot be able to differentiate using the naked eye that this liquid is an acid, this liquid is a base, and they all look the same as they are all colorless like water. Therefore, we use an indicator in order to differentiate or tell us if this liquid is an acid, this liquid is neutral, or this liquid is a base.